Hello. Our goal here today is to write nuclear equations. So there's nothing really new happening here. We're just trying to fill out this blank. So we're going to talk later in class that platinum can decompose. It can turn into helium and something else. And I want to know what that something else is. And we use these numbers to help figure it out. So this number down here is the atomic number. Platinum is 78. And helium is 2. That means platinum has 78 protons, and helium has 2 protons. So whatever thing this is, that thing has to have a certain number of protons. And that thing has to have how many? Well, 78 minus 2. It has to have 76 protons. Something with 76 protons, because 78 minus 2 is 76, has to be the element osmium. Perfect. So you just figured out what it is, what the element is, how many protons, then you just need this number up here. Platinum has a 175 mass number. That means there's 175 things in the nucleus. Helium has 4. This thing has to have the rest of the mass. 175 minus 4 is 171. We just wrote a chemical equation for something going on in the nucleus. That's interesting. All I need you to do right now is try to figure out how to fill in the blanks. This one's a little more interesting. This sucker right here is a beta particle, but it's also just called an electron. It has 0 mass and a -1 charge. So same game. Potassium has an atomic number of 19. That means it has 19 protons. An electron doesn't have any protons. Matter of fact, we can think of it as having -1 protons. So this thing right here, the only way to make the two sides equal, 19 protons and -1 proton, is this thing must have 20 protons. I look on the periodic table. Anything with 20 protons is calcium. And then the only number I need to figure out is how much mass. What's the mass number of this calcium? Well, potassium is 40. The electron doesn't change the mass. So calcium must also have 40 mass. These are writing nuclear equations. There's really interesting chemistry going on here, but the goal that we have in this DLD is just to figure out how to fill in the blanks. Finally, this is something called fission. Fission lets out a lot of energy. This is uranium fission. Uranium gets hit with a neutron. A neutron has 1 mass but 0 protons. And it turns into barium, turns into 3 more neutrons, and something else. Now these are harder. There's a lot of things to work out. If you don't get this one kind of mastered in your DLD, that's okay. I'm hoping that you get some of these easier ones figured out. But let's try this game. On this side of the arrow, there's 92 protons and 0 protons. So that's 92. On this side of the arrow, there's 56 protons and 0 over here. So 92 minus 56, this thing right here has 39 protons. I look on the periodic table. Anything with 39 protons has to be krypton. Sweet. I think you can do that. I bet you're doing great right now. This number is a little bit harder. That's the total amount of mass. It has to be conserved. So there's 236 mass on this side. There's 141, but there's 3 more right here. So that's 141, 142, 143, 144, 236, and 144. This has to make up the difference, so I do the subtraction. This has to have 92 mass. 39 protons and the rest neutron. This is your goal. I hope it goes well. Good luck, and I'll see you next time.